Hey guys, tonight we're going to step into a story, a thought experiment, and a lullaby all at once. Take a moment to lie back, close your eyes if you feel comfortable, and let your mind drift. We're going to leave the familiar comfort of our Earth, our Moon, and our own gentle sun. We're going to imagine a new home for our planet, a home so vast and so alien that the laws of physics as we know them begin to sing a different, much stranger tune. It's a journey into the heart of a cosmic giant, a stellar behemoth that makes our own star look like a tiny flickering candle. A place where the sky would be painted in colors we've never seen, and where time itself might feel a little heavier. So before you get too comfortable, and trust me, you probably wouldn't survive the trip, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. If you're new, a warm welcome. I'd love to know where in the world you're listening from and what time it is for you right now. It's a strange and beautiful thought that we're all here together, a tiny network of minds drifting through the cosmos. Now let's begin our journey. Imagine, if you will, the gentle hum of our own world, the steady, reliable light of our sun, a star we've known and depended on for billions of years. Our sun is a comfortable, middle-aged star, a yellow dwarf that has provided the perfect conditions for life to blossom. It's a star that we've come to understand, to map, to predict. Its light, its heat, its gravity, they are the very foundation of our existence. We are a part of its family, its children orbiting in a predictable, safe dance. But what if that dance was to change? What if our planet, our little blue marble, was to be plucked from its comfortable home and placed into the gravitational embrace of something else? Not just any star, but the largest known star in our corner of the galaxy. A star so large that if you placed it at the center of our solar system, its surface would extend far beyond the orbit of Jupiter. A star named Scuti. Scuti is a hypergiant, a star that exists on the very edge of our understanding of stellar physics. It's not just big. It's a cosmic monarch, a truly mind-boggling entity of light and mass. When we talk about large in a cosmic sense, our human-scale comparisons fall apart almost instantly. Our sun, for example, is a comfortable 1.4 million kilometers in diameter. A quick trip in a commercial jet from one side to the other would take you roughly 150 years, but Scuti, its diameter is a staggering 2.4 billion kilometers. To put that into perspective, a photon of light, the fastest thing in the universe, would take nearly 7 hours to travel from one side of Scuti to the other. To cross our sun, that same photon takes a mere 8 seconds. This is the scale we are dealing with, a scale that makes the very idea of Earth orbiting it feel like a tiny speck of dust attempting to circle a colossal furnace. So let's begin our thought experiment. We are now in a universe where Earth has been magically, impossibly transported to a new home. Our sun is gone, a distant memory, a faint flicker in the cosmic rearview mirror. Our new sun is Scuti. The first thing you would notice, even before the catastrophic effects began, would be the sheer visual shock. The sky would no longer be a vast canvas of blue with a distant golden orb. The entire sky, day and night, would be a fiery, turbulent ocean of red and orange. Scuti is a red hypergiant, and its light would bathe our planet in a perpetual blood-red sunset. But it wouldn't be a gentle light. It would be an all-encompassing, oppressive brilliance, a brightness so intense that the very air would feel thick with it. The concept of a day and night would be completely redefined. Scuti would fill such a large portion of our sky that the concept of a sunrise or a sunset as we know it would cease to exist. There would be no transition, no soft gradient of colors. Instead, there would be a constant, overwhelming presence. Our planet would be so close to the star's surface. Remember, we are imagining an orbit, but one so close that it's nearly grazing the star's atmosphere, that the sheer scale of it would be terrifying and beautiful all at once. The sky would be a canvas of swirling plasma, gigantic sunspots, and coronal loops that would dwarf our entire planet. You would look up and not see a star but a world of fire and light, a churning sea of incandescent gas. The atmosphere itself would be a casualty of this new reality almost immediately. Our atmosphere, a delicate blanket of nitrogen and oxygen, is a fragile thing. It's held in place by our planet's gravity, and it's protected from the solar wind by our magnetosphere. But Scuti's stellar wind would be a different beast entirely. It's not a gentle breeze. It's a cosmic hurricane of charged particles, a torrent so powerful that it would strip away our atmosphere like an onion peel. Our magnetosphere, the protective bubble around Earth, would be overwhelmed in a matter of hours, if not minutes. The compasses would spin wildly, and the auroras, those beautiful dancing lights at our poles, would become a terrifying sky-wide spectacle. The sky would be a constant, violent display of cosmic radiation as particles from Scuti collided with the last remnants of our atmosphere. The oceans, too, would boil away. The temperatures would be unimaginable. At such a close distance to a star of this magnitude, the heat would be instant and all-consuming. The surface of our planet would melt, the mountains would turn to molten slag, and the continents would become a sea of glowing lava. The very definition of land and sea would be rendered meaningless. We've all seen images of volcanic eruptions of molten rock flowing like a slow, fiery river. Now imagine the entire surface of Earth as one massive planetary-scale volcanic eruption. The heat would be so intense that even the very rocks would begin to vaporize, turning the surface into a thick, glowing mist. This raises an interesting question in this new reality. Would the concept of a solid state even exist? Could we even say that Earth is a planet in the traditional sense? It would be a fiery gaseous orb, a satellite of a star that is essentially a cosmic furnace. The very particles that make up our world, the atoms and molecules of rock and water and air, would be stretched and torn apart by the immense gravity and heat. We are used to a universe of neat, predictable categories: stars, planets, moons. But in a place like this, those definitions blur and break down. Our little planet would cease to be what it was, becoming something else entirely, a new fiery entity in a truly alien system. But what about the core of our planet? The very heart of the world, a molten sea of iron and nickel churning and generating the magnetic field that protects us. It, too, would be affected. The tidal forces from Scuti's immense gravity would be so powerful that they would literally stretch and squeeze Earth. The planet would no longer be a perfect sphere. It would be elongated, a cosmic egg being pulled apart. This constant kneading of the planet would generate an incredible amount of internal friction and heat, causing the molten core to churn even more violently. The tectonic plates would be in a state of perpetual motion, a frantic, deadly dance of continental shifts and earthquakes. The Earth, in essence, would be tearing itself apart from the inside out, a symphony of destruction played out on a planetary scale. And what about life? The most precious, most fragile thing we have. Life as we know it is a delicate balance of conditions. The right temperature, the right pressure, liquid water, all of that would be gone. The most resilient forms of life, the extremophiles that live in the deepest, darkest trenches of our oceans, would be the last to go. But even they, with all their incredible adaptations, would not be able to withstand the heat and radiation. The oceans would boil away, the hydrothermal vents would run dry, and the last vestiges of life would be erased. It's a sobering thought, isn't it? The incredible complexity and beauty of life, all of it reduced to nothing more than a momentary flicker in the vastness of time and space. The final desperate song of a dying world. This brings us to one of the deepest mysteries of science, a concept that physicists still struggle to fully grasp the nature of hypergiants themselves. How can a star get so big? We understand the life cycles of stars, from the birth of a nebula to the gentle fade of a white dwarf or the violent explosion of a supernova. But a star like Scuti challenges these models. It's a star that's not just burning fuel, it's shedding its outer layers at a phenomenal rate, creating a vast envelope of dust and gas around it. It's a star that is essentially on its last legs, a cosmic heavyweight that is slowly, majestically disintegrating. It's a beautiful, terrifying reminder that even the most immense and powerful things in the universe are not eternal. They are born, they live, and they die. And in this journey, our little planet would be nothing more than a footnote, a momentary distraction in the final act of a cosmic drama. And so we find ourselves at the beginning of our story. Our Earth, a planet we hold so dear a home we've spent so much time exploring and understanding, is now a tiny fiery satellite of a cosmic king. The sky is an inferno. The ground is a sea of lava, and the air is a torrent of radiation. Life is a memory, and the gentle hum of our world has been replaced by the roar of a star. This isn't a story of survival. It's a story of transformation of a planet being remade by forces we can only barely comprehend. It's a story that asks us to let go of our preconceived notions, to embrace the impossible, and to find a strange melancholic beauty in the cosmic unknown. We left our planet in a state of impossible transformation, its gentle blue surface now a fiery ocean under a colossal red star. But let's take a step back from the immediate inferno and consider the nature of Scuti itself. Our Sun, a star we know so well, is a comfortable reference point. It's a ball of hydrogen and helium, a thermonuclear reactor that has been fusing these elements for billions of years, creating light and heat. It's a star that we've used as a kind of cosmic ruler, a standard by which we measure the size and brightness of all other stars. But Scuti shatters that ruler into a million pieces. It's a different kind of star, a red hypergiant, a type of cosmic celebrity that lives fast and dies young. Imagine our solar system as a small, quiet neighborhood. The sun is the cozy house at the center. Now imagine a new neighbor moves in one so large that its property line extends past Jupiter's house. This is the scale we're talking about with Scuti. Its diameter is so immense that if our sun were a single grain of sand, Scuti would be a beach ball. Its volume is roughly 5 billion times that of our sun. Let that sink in. 5 billion. It's not a number our brains are built to comprehend. We can say the words, but the true scale remains a misty, abstract concept. The light from our sun takes 8.3 minutes to reach us. The light from Scuti, traveling at the same incredible speed, would take hours to cross its own diameter. This simple fact alone gives us a glimpse into a cosmic reality that defies our everyday intuition. The star's immense size is a result of its rapid, furious life. Stars like our sun burn their fuel at a steady, predictable rate. They have a long, stable life. But hypergiants, like Scuti, are different. They are born from massive clouds of gas and dust, and they begin their lives as incredibly hot blue stars. They burn through their nuclear fuel at a terrifying pace, fusing elements in their cores with a ferocity that a star like our sun can only dream of. This rapid burning creates enormous amounts of energy and outward pressure, causing the star's outer layers to expand dramatically. It swells and swells until it becomes a hypergiant, a bloated, majestic, and unstable ball of gas. This isn't a state of calm stability. It's a phase of frantic, glorious decay. This instability is a core part of Scuti's identity. Hypergiants are known for being highly variable stars. They don't just shine with a steady light. They pulse, they throb, they change in brightness and size. They shed their outer layers in violent, unpredictable outbursts. So our Earth wouldn't be orbiting a stable, predictable star. It would be orbiting a chaotic, pulsating giant, a star that is constantly changing its form and intensity. This would make our new day a truly terrifying experience. The light and heat would not be constant. They would surge and ebb, like the breath of a sleeping monster. One moment the sky might be a searing crimson, the next a slightly darker shade as the star's pulse shifts. The temperature on Earth's surface, already unimaginably hot, would fluctuate with these cosmic heartbeats, creating a new and deadly rhythm. A lesser-known scientific fact about these types of stars is that their sheer size means their surface gravity is surprisingly weak. Even though Scuti is incredibly massive, its mass is spread out over such a colossal volume that the gravitational pull at its surface is much less than at the surface of our Sun. The star's gas and plasma are held in a tenuous embrace, a cosmic membrane that is constantly being blown away by the internal pressure. This is why we see this vast, dusty envelope around the star. It's a star that is literally shedding itself into space, its very existence, an act of slow, majestic disintegration. This raises a fascinating paradox. An object with such immense mass that it warps space-time itself also has a surface so diffuse that you might be able to fly through it. So let's return to our perspective on Earth, a tiny speck of dust in this cosmic storm. Our planet, once so well defined, is now being bathed in this turbulent, pulsing light. The immense gravity of Scuti, even from a distance that would put us well inside our own solar system, would be a new and powerful force. The tidal forces, as we mentioned, would be immense. But let's delve a little deeper into what that means. We are familiar with the moon's gravitational pull on our oceans, creating the tides we see every day. The moon is a small rock, and its effect is significant but manageable. Now imagine a tidal force from a star with a mass hundreds of times greater than our Sun at a much closer distance. The entire solid crust of Earth would be affected. The continents would rise and fall like waves on a cosmic ocean. The mountains would be stretched and compressed, and the earthquakes would not be a rare event, but a constant, grinding reality. The core concept we're touching on here is gravitational tidal locking. Just as the moon is tidally locked to Earth, showing us only one face, our planet might eventually become tidally locked to Scuti. But this wouldn't be a gentle locking. It would be a violent wrenching process. The immense gravitational pull would slow Earth's rotation, stretching and squeezing it until one side of the planet was in a perpetual fiery day and the other was in a perpetual glowing night. The day side would be an unimaginable inferno, a landscape of molten rock and vaporized metals. The night side, while still incredibly hot from the ambient light of the star and the heat from the molten core, might offer a strange, dark, and still deadly contrast. This idea of a tidally locked planet brings us to a beautiful and slightly tragic philosophical question. Would our planet retain any sense of its former self? Or would it be fundamentally remade, a new entity born of fire and gravity? The mountains, the oceans, the very air we breathed, all of it would be gone. The planet would be a new world, a fiery globe of molten rock. The legacy of our world would be erased, leaving no trace of the life and history that once existed here. This is a sobering thought, a quiet reminder of our place in the cosmic order. We are a part of a small, fragile system, and our existence is entirely dependent on the gentle, stable nature of our star. The atmosphere of Scuti itself is also a fascinating and terrifying thing. It's not a dense, hot layer of gas like our Sun's chromosphere. It's a vast, diffuse envelope of plasma, a tenuous cloud of gas that is constantly being shed into space. Our planet, in its close orbit, would be effectively flying through the outer fringes of this atmosphere. The friction alone, even from this thin gas, would be immense. Our orbit would decay, and our planet would slowly but surely begin to spiral inward, a slow and agonizing dance towards its fiery end. It wouldn't be a sudden plunge. It would be a long, drawn-out process, a gradual descent into the heart of the star. And what about the other planets, Jupiter, Saturn, Mars? They would still be there in their orbits, but their reality would be completely transformed. Their skies would be dominated by the giant red orb of Scuti. Their familiar solar systems would be gone, and they would become satellites of a new king. Jupiter, the giant of our solar system, would suddenly look small in comparison. Its familiar bands and storms would be bathed in the strange red light of the hypergiant. The gas giants might even begin to shed their own atmospheres under the immense stellar wind, a slow and majestic process of cosmic erosion. So in this section, we have begun to see the true nature of our new home. It's not just a big star. It's a cosmic titan, a frantic, glorious being on the edge of its own existence. Our Earth, in its new orbit, is a silent witness to a cosmic drama, a slow, beautiful, and utterly deadly dance. The gentle hum of our old world is gone, replaced by the roar of a new terrifying reality. We have left the comfortable and entered the impossible. We've journeyed through the immediate inferno and the colossal scale of Scuti, but now we must confront a force both constant and elusive, time itself. On our small familiar Earth, time flows in a steady, predictable rhythm. We measure it with clocks, mark it with seasons, and feel its passage in the changing of our bodies and the growth of trees. We perceive it as a constant, a universal river that carries all things forward at the same rate. This is our everyday reality, a comfortable illusion that works perfectly well for our lives on a small, gentle planet. But in the gravitational embrace of Scuti, that illusion begins to shatter. The river of time doesn't flow at a single uniform speed. It is bent, stretched, and twisted by the sheer force of the star's mass. This is the core concept of time dilation, a profound and beautiful prediction of Albert Einstein's theory of general relativity. The theory posits that gravity isn't a force in the traditional sense pulling objects together. Instead, it's a warping, a bending of the very fabric of space-time itself. Imagine a bowling ball placed on a trampoline. The bowling ball creates a dip in the fabric, and a small marble rolling nearby will be drawn into that dip. That's how we can visualize gravity. Now replace the bowling ball with Scuti, a star so massive it's like a cosmic cannonball on the trampoline of the universe. The dip it creates would be immense, a well of space-time so deep that everything within its influence would be altered. Our Earth, orbiting in this immense gravitational well, would experience time differently. For us on the surface of our planet, a second would still feel like a second. Our heartbeats would tick at their familiar pace, and our internal biological clocks would continue to function as they always have. But if someone were to be far away observing our fiery planet from a great distance, say from the edge of the solar system, where the pull of Scuti is much weaker, they would see something truly bizarre. To their clocks, our clocks would appear to be ticking slower. The events on our planet, the slow, fiery dance towards destruction, would unfold at a more leisurely pace. From their perspective, a minute on Earth might be an hour for them. This isn't just a hypothetical thought experiment. It's a proven scientific fact. We use atomic clocks on Earth and compare them to clocks on GPS satellites. The satellites are further away from Earth's gravitational pull, so their clocks tick slightly faster. We have to constantly correct for this discrepancy to ensure our navigation systems work properly. This tiny everyday effect is a whisper of the colossal truth that would be screaming in our new reality. With Scuti, the effect would be magnified to an almost unimaginable degree. The difference in the flow of time between a point on Earth's surface and a point a few 100 million kilometers away would be profound. This raises a mind-bending question, a paradox that has fascinated scientists for decades, the twin paradox. Imagine if we had two identical twins. One stays on our fiery, time-dilated Earth, and the other twin is somehow able to escape to the far reaches of space away from Scuti's influence. The twin on Earth would age slower. When they were finally reunited, an impossible, beautiful reunion, the twin who stayed on Earth would be significantly younger than their sibling, who traveled through space. It's a beautiful, tragic thought, a reminder that time is not a constant, but a flexible, malleable thing, a river whose flow is determined by the gravitational landscape it travels through. And what about the star itself? UI. Scuti is so massive that the time dilation at its surface would be immense. A second on its fiery surface would be a slow eternity for someone far away. The star is not just a source of light and heat. It is a clock, a gravitational anchor that distorts and redefines the very essence of how we measure existence. This brings us back to our perception. The universe we know is full of stories. We tell stories about how things began, how they will end, and what happens in between. But what if the very framework of our stories, the linear cause and effect progression of time, is just an illusion, a local phenomenon that only applies to our corner of the universe? This is one of the unsolved mysteries of physics. We understand how gravity warps space-time, but we don't fully understand the true nature of time itself. Is it a dimension like space? Can it be reversed? Or does it only ever flow forward? The immense gravity of a star like UI Scuti gives us a glimpse into these questions. A cosmic laboratory where the rules we've come to accept are broken and remade. The effects of time dilation would not just be theoretical. They would be a fundamental part of our planetary existence. As we mentioned, our planet is now a glowing orb of molten rock. The slow, constant geological processes, the churning of the core, the movement of the tectonic plates, the slow release of heat would be unfolding at a different rate from the perspective of an outside observer. The planet's fiery life and eventual demise would be a long drawn-out cosmic drama, a slow-motion catastrophe played out on an astronomical scale. For us on the surface, everything would seem to be happening at normal speed. But from a distance, our world would be a slow, burning candle, its fiery glow, a testament to a different kind of temporal reality. This idea of time as a woven tapestry is a powerful metaphor. Our small everyday lives are a single thread in this tapestry. We see the thread from our own perspective, flowing straight from birth to death. But a cosmic weaver, a being with a broader perspective, would see the entire tapestry at once. They would see our thread as it bends and warps around the gravitational dip of UI Scuti, a beautiful and complex curve in the fabric of existence. Our lives, our loves, our fleeting moments of joy and sorrow. All of it is just a small, beautiful pattern in a larger, more mysterious design. And what about memory? Memory is inextricably linked to our perception of time. We remember things in a linear fashion, as a series of events from the past, leading to the present. But what if our very memory, our sense of a personal history, was being subtly stretched and warped by the gravity around us? Could we feel the weight of time, the slow, heavy pull of the star? It's a question that drifts into the realm of philosophy and poetry, a beautiful and unsettling thought. Our minds, our consciousness, the very essence of who we are, would be a part of this cosmic dance, a tiny fragile thread in the immense bending tapestry of space-time. This is the deeper, more profound layer of our story. Beyond the fire and the fury, beyond the impossible scale of the star, lies a quiet, almost melancholic truth. We live in a universe where the very rules we depend on, the laws of space and time, are not universal constants. They are local phenomena shaped and molded by the immense forces that govern the cosmos. Our journey into the heart of UI Scuti is not just a story about a planet's end. It's a story about the fragility of our assumptions, a lesson in humility, and an invitation to see the universe not as a fixed, rigid place, but as a fluid, ever-changing ocean of possibility. Our journey has taken us from the fiery surface to the bending of time itself. But let's now turn our attention to the one thing we all take for granted: the sky. On Earth, our sky is a familiar and comforting presence. It's a vast dome of blue, an atmospheric ocean of gas that scatters sunlight in a way that gives our world its iconic hue. At night, it's a canvas of deep black velvet, dotted with the gentle pinpricks of distant stars. But in the gravitational embrace of UI Scuti, that canvas would be entirely remade. The new sky would be a testament to the star's colossal size and strange composition, a continuous turbulent masterpiece of color and light that would redefine our very perception of what a sky can be. The first and most striking change, of course, would be the color. Our sun is a yellow dwarf, and its light is a balanced spectrum of all colors. Our atmosphere scatters the blue light more effectively than the other colors, which is why we see a blue sky. But Scuti is a red hypergiant. Its light is not a balanced, even glow. It's a spectrum heavily biased towards the red and orange end. The star's surface temperature is cooler than our sun's, but its sheer size means it emits an incredible amount of light. The light that reached our planet would be an all-encompassing deep red. The sky would no longer be blue. It would be a perpetual searing crimson, a sky that would feel less like a gentle blanket and more like a colossal living furnace. Imagine looking up. The entire celestial dome would be filled with the roiling, turbulent surface of Scuti. It wouldn't be a uniform color. The star's photosphere, the visible surface, is not a calm, even expanse. It's a boiling, chaotic sea of plasma with immense convection cells, huge bubbles of hot gas rising from the star's interior, cooling, and then sinking again. These cells, some of them larger than our entire sun, would be visible from our planet. We would see a sky full of immense, swirling patterns of light and shadow, a constant mesmerizing and terrifying dance of cosmic energy. It would be like looking directly into a fire, but a fire so vast that it would fill our entire field of vision. The concept of a sky is built on the idea of a distant horizon, a place where the Earth meets the atmosphere. But with a star so large, the horizon would be gone. Scuti would fill such a large portion of the sky that there would be no clear lines separating the ground from the star. The fiery surface of the star would seem to meet the molten landscape of our planet, creating a seamless, terrifying union of fire and rock. The concept of up and down would feel less about gravity and more about the immense, overwhelming presence of the star above us. A lesser-known scientific fact about hypergiants is that they are surrounded by vast, diffuse envelopes of dust and gas. This is the material the star has been shedding throughout its turbulent life. This dust and gas would play a crucial role in the new sky. It wouldn't just be the star's light. It would be that light filtered through a cosmic haze of silicate dust, carbon soot, and other heavy elements. This would create a phenomenon similar to the beautiful sunsets and sunrises we see on Earth, but on a planetary scale and in a perpetual state. The light would be scattered and refracted by these fine particles, creating a new alien palette of colors. Imagine a sky that is a constant shimmering display of deep reds, hazy oranges, and maybe even a faint, eerie magenta from the ionized gas. It would be a sky that is beautiful in its own terrifying way, a celestial show of cosmic proportion. This brings us to one of the most profound and unsettling mysteries of science, the nature of color itself. We perceive color as a property of light, but it's really a creation of our brains. Our eyes detect different wavelengths of light, and our brains interpret those signals as colors. We've evolved to see the world in the spectrum of our sun. But what would happen if our eyes and our brains were bathed in a completely different spectrum? Would we still see the same colors? Or would our perception be subtly, fundamentally changed? The world would be remade not just in its physical reality, but in the very way we perceive it. The color red, a color we associate with warmth. Danger and passion would become the new normal, the very essence of existence. And what about the stars we used to see? The familiar constellations, the gentle shimmer of the Milky Way. They would be completely invisible. The overwhelming light of Scuti would blot them out entirely, a light so bright that it would make all other light sources seem insignificant. The sky would be a single monolithic object, a constant reminder of our new isolated reality. Our planet, once a part of a vast and beautiful galaxy, would be trapped in the suffocating embrace of a single colossal star. The vastness of the universe would be lost to us, replaced by the overwhelming, all-consuming presence of Scuti. The radiation would also play a key role in the sky's appearance. The stellar wind, that powerful stream of charged particles we discussed earlier, would constantly be interacting with the last remnants of our atmosphere. This would create a continuous all-sky aurora. On Earth, auroras are beautiful dancing lights at the poles, a sign of our magnetosphere doing its job. But here, with the magnetosphere long gone, the auroras would be a violent, planetary-wide spectacle. The sky would be a constant, shimmering display of greens, purples, and blues, a ghostly dance of cosmic radiation, playing out in front of the crimson backdrop of Scuti. It would be a beautiful and deadly light show, a final act of atmospheric defiance before our planet's final disintegration. This raises another philosophical question. What is the meaning of beauty in a place like this? We find beauty in nature, in the colors of a sunset, in the dance of a fire. But these are all things we can control or understand. What about a beauty that is so immense, so terrifying, that it threatens to overwhelm us completely? Is a fiery, roiling sky a thing of beauty? Or is it simply a spectacle of destruction? The answer perhaps lies in the eye of the beholder, a final poignant question about the nature of our own consciousness and our ability to find meaning in even the most hostile of environments. The new sky would not just be a visual spectacle, it would be a soundscape. The intense turbulence and convection of Scuti's surface would create immense sonic waves, pressure pulses, that would travel through the vacuum of space. While we wouldn't hear them in the traditional sense, they would be a part of the reality, a silent roar of cosmic energy that would constantly be bombarding our planet. It would be a place of perpetual noise and constant light, a new kind of sensory experience that would be both overwhelming and unforgettable. And so we have seen our sky remade. The gentle blue has been replaced by a searing crimson, the distant stars by a roiling, turbulent spectacle of cosmic fire. The familiar comfort of day and night is gone, replaced by a constant, overwhelming presence. Our planet in its new home is not just being physically remade, its very reality is being transformed, its sky becoming a mirror of the colossal, beautiful, and terrifying star it now orbits. The gentle hum of our old world is now a silent scream, a final testament to the immense and beautiful power of the cosmos. We've explored the visual and temporal transformations, but now we must confront the very force that would strip our planet bare, the stellar wind. On our Earth, we are protected by an invisible shield, a beautiful and powerful force field generated by our planet's core. This is our magnetosphere, a bubble of magnetic energy that deflects the solar wind, a constant stream of charged particles from our sun. The solar wind, while a gentle hum by cosmic standards, is still a powerful force, and our magnetosphere is what keeps it from stripping away our atmosphere and bombarding our surface with harmful radiation. Without it, life as we know it would be impossible. But now, in our new reality, that gentle hum has been replaced by a cosmic hurricane. Scuti, as a red hypergiant, is not a calm and stable star. It's a star in the final turbulent stages of its life, shedding its outer layers at a phenomenal rate. This process creates an incredibly powerful stellar wind, a torrent of charged particles and radiation that makes our own sun's solar wind look like a gentle whisper. This stellar wind would be a ceaseless, overwhelming assault on our little planet. It wouldn't be a gentle breeze. It would be a cosmic blast of protons and electrons traveling at incredible speeds and unending destructive force. The first casualty of this new reality would be our magnetosphere. The magnetosphere is a delicate balance of forces, a bubble created by the churning molten iron in Earth's core, pushing back against the force of the solar wind. With Scuti's stellar wind, that balance would be shattered. The pressure from the stellar wind would be so immense that our magnetosphere would be overwhelmed in a matter of hours, if not minutes. The compasses, once reliable guides pointing north, would spin erratically as the magnetic field of our planet was torn and twisted by the sheer force of the incoming particles. The protective bubble would collapse, leaving our planet exposed and vulnerable. This would have immediate and catastrophic consequences for our atmosphere. Our atmosphere, a fragile blanket of gas, is held in place by our planet's gravity. But a significant portion of it is also kept from being blown away by the protective magnetosphere. With that shield gone, the stellar wind would begin to strip away our atmosphere atom by atom, molecule by molecule. It would be a slow but relentless process of atmospheric erosion. The lighter elements, like hydrogen and helium, would be the first to go. But eventually even the heavier elements, like oxygen and nitrogen, would be blown away into the vacuum of space. The beautiful crimson sky we imagined would be a fleeting spectacle, a final glowing testament to the planet's last breath before it became a bare rocky orb. A little-known scientific fact about stellar winds is that they play a crucial role in shaping the cosmos. They are responsible for creating beautiful celestial objects, like the huge clouds of gas and dust that surround stars. And they can even trigger the birth of new stars by compressing gas clouds. But for a planet, a stellar wind of this magnitude is not a creative force. It's a destructive one. It's a force of entropy, of disorder, a constant push towards the disintegration of everything we know. It's a cosmic whisper that says nothing is permanent and everything must eventually return to the chaos from which it came. The loss of our atmosphere would also have a profound effect on the planet's surface. Without a protective blanket of air, the pressure would drop to near vacuum. The oceans, already boiling from the immense heat, would vaporize instantly in this low-pressure environment, flash boiling into a thick, planetary-wide steam. This steam would then be quickly carried away by the stellar wind, leaving behind a dry, desolate, and incredibly hot surface. The planet would become a husk, a bare rock being bombarded by a continuous stream of cosmic radiation. And what about the radiation itself? On Earth, we are protected from the worst of the sun's radiation by our atmosphere and magnetosphere. The ozone layer, a thin band of molecules high in our atmosphere, absorbs the harmful ultraviolet radiation. But in our new reality, there would be no ozone layer. There would be no atmosphere to speak of. The surface of our planet would be constantly bathed in a deadly stream of high-energy particles, X-rays and gamma rays. This would not just be a threat to life, it would be a threat to the very structure of matter itself. The very molecules that make up rock and soil would be ionized and broken apart by this relentless bombardment. This raises an interesting question. Is a planet without an atmosphere truly a planet? Or is it something else entirely? The definition of a planet includes having enough mass to be rounded by its own gravity and to have cleared its orbit of other debris. But our planet in this new reality would be a hollowed-out fiery orb, its protective layers gone, its familiar features erased. It would be a ghost of its former self, a silent monument to the power of Scuti. The stellar wind would also affect the orbit of our planet. The constant stream of particles and the friction of the star's tenuous outer atmosphere would create a drag, a force that would slowly but surely pull our planet closer to the star. It's a subtle force, a quiet and constant pull, but over the course of time it would be an inescapable one. The planet would be on a slow and agonizing death spiral, its orbit decaying its fate, sealed from the very moment it entered the embrace of the hypergiant. This slow decay is a beautiful melancholic metaphor for the concept of entropy. Entropy is the idea that the universe is constantly moving from a state of order to a state of disorder. Our planet, a beautifully ordered system of life and geology, is now being slowly and systematically unraveled. The stellar wind is a force of entropy, a constant push towards chaos and dissolution. The beautiful complex patterns of our world, the seasons, the tides, the cycles of life, are being replaced by the simple chaotic order of a planet being torn apart. And so we've seen our planet's shield destroyed, its atmosphere stripped away, and its surface exposed to a deadly torrent of radiation. The gentle hum of our own sun's wind is now a roar, a powerful and destructive force that is slowly but surely unmaking our world. Our journey is not just about what a star can do. It's about what a planet can lose. It's a story of vulnerability, of fragility, and a quiet reminder that our existence is a delicate balance, a fleeting moment of order in a universe that is constantly moving towards chaos. Our planet has become a glowing husk, its atmosphere a memory carried away on a cosmic wind. But as we mourn the loss of our familiar world, we must remember that our story is just one small thread in a much larger tapestry. Scuti. This colossal star is not an isolated entity. It exists within a vast and complex neighborhood, a galactic backdrop that would also be transformed by its presence. Our new reality isn't just about our planet and its star. It's about the entire cosmic environment that now surrounds us, a silent dance of cosmic dust and stellar remnants. As a red hypergiant, Scuti is not a clean and tidy star. It is a star in a state of constant, slow-motion explosion. Throughout its life, and particularly in its final turbulent stages, it sheds enormous amounts of material into space. This material, a mixture of heavier elements forged in its core, as well as unburnt hydrogen and helium, forms a vast, diffuse envelope around the star. We are no longer in the clean, open space of our old solar system. We are now in the midst of a colossal turbulent cloud of cosmic dust and gas. Imagine the serene emptiness of space replaced by a constant, gentle snowfall. Not of frozen water, but of silicate grains, carbon dust, and microscopic iron particles. This is the stellar wind we discussed earlier, not just as a torrent of charged particles, but as a slow, constant rain of solid matter. This would make our orbit a treacherous place. Our planet, already a molten orb, would be constantly bombarded by these microscopic particles, while not as destructive as a full-scale meteor shower. This constant peppering would add to the overall heat and friction, a subtle but relentless force acting on our planet. This cosmic dust would also affect the light from Scuti. Just as the smoke from a fire can change the way the light looks, this vast cloud of dust would filter and scatter the star's crimson light, creating a new and alien sky. The light would not be a clean, direct glow. It would be a diffuse, hazy radiance. We might see beautiful ethereal nebulae in the vast expanse of the dust cloud, lit from within by the immense light of the star. It would be a sky of subtle gradients and shifting shadows, a new kind of beauty, born from the ashes of a dying star. A lesser-known scientific fact is that this type of cosmic dust is not just a form of pollution. It is the raw material for the next generation of stars and planets. The heavy elements forged in the heart of Scuti and other massive stars, the carbon, oxygen, and iron that are the building blocks of our own world, are scattered into space when they die. This dust eventually clumps together in vast clouds, and under the force of gravity, these clouds collapse to form new stars and new planets. Our existence and the existence of our planet is a direct result of this cosmic cycle of death and rebirth. We are quite literally made of stardust. So in our new reality, our planet is orbiting not just a star but a cosmic graveyard. The dust and gas around Scuti are the ghosts of its past, the remnants of a life lived in a furious blaze. This raises a profound philosophical question. Does our journey into this cosmic neighborhood have a purpose beyond destruction? Could our planet, in its final moments, become a new source of raw material, a tiny contribution to the eventual birth of a new celestial body? It's a humbling thought, a quiet reminder that even in our destruction, we might be playing a small part in the larger cosmic narrative. The concept of a new planetary neighborhood also brings us to the question of other planets. Our own solar system is a neatly ordered family with the planets in their stable, predictable orbits. But Scuti's immense gravity and chaotic nature would have a profound effect on any other planets in its system. They would not be in a calm, stable dance. They would be pulled, tugged, and flung around by the sheer gravitational force, their orbits becoming wild and unpredictable. The cosmic dance would be less of a graceful waltz and more of a frenzied mosh pit. Our planet would be a silent witness to this chaos. We might see other planets once as stable and serene as our own being torn apart by tidal forces, their moons being ripped from their orbits, and their very existence being rendered impossible. This is the reality of a hypergiant system. It is not a place of order and stability. It is a place of beautiful, terrifying chaos. And what about the other stars in the galaxy? From our new vantage point, our perspective would be completely different. The gentle arc of the Milky Way, once a beautiful band of light across the night sky, would be completely obscured by the light and dust of Scuti. We would be isolated, a small fiery island in a sea of red. The universe would have shrunk our cosmic neighborhood, reduced to a single overwhelming star and the turbulent chaos that surrounds it. This isolation is a powerful metaphor for our own experience. We are often so focused on our own lives, our own stories, that we forget the vastness of the world around us. We get caught up in the details and miss the larger picture. Our journey into the heart of Scuti forces us to confront this isolation, to see our own world not as the center of the universe, but as a tiny, fragile speck of dust in a vast and beautiful, but also terrifying cosmic ocean. The silent dance of cosmic dust, the ghosts of a star's past, the chaos of a new planetary neighborhood, all of it is a reminder of the beautiful cyclical nature of the universe. Nothing is ever truly destroyed. It is simply transformed. The matter that made up our oceans, our mountains, and our very bodies will not simply cease to exist. It will be scattered, reforged, and eventually one day become a part of something new. Our story in its final fiery act is not an ending. It is a new beginning, a tiny contribution to the grand ongoing symphony of the cosmos. We've observed the destruction from a distance, but now let's ground ourselves in the immediate visceral experience of our new reality. Our planet, now a fiery molten orb, is not a passive victim. It is an active participant in a violent, chaotic dance with its new star. The serene stability of our old world, with its gentle tides and slow geological processes, has been replaced by a constant, frantic struggle against an overwhelming force. We must now explore the crushing, relentless power of gravity, a force so profound in Scuti's embrace that it would reshape Earth's very foundation. On our old Earth, gravity is a constant, gentle pull that keeps our feet on the ground and our atmosphere in place. We are so used to it that we barely notice it. But Scuti's gravity is a different beast entirely. While we established that the surface gravity is weaker due to its immense size, the tidal forces it exerts on our orbiting planet are beyond our comprehension. Tidal forces are not a simple pull. They are a differential force, a stretching and squeezing that occurs because the gravitational pull is stronger on the side of the planet, closer to the star, and weaker on the far side. Our moon's gravity creates the tides in our oceans, a gentle rise and fall of water. With Scuti, this same force would be applied to the solid rock of our planet, and it would be 1,000,000 times stronger. Imagine the Earth as a ball of clay. The immense tidal forces of Scuti would constantly knead and squeeze this clay ball, stretching it into a prolate spheroid, a shape resembling a cosmic egg. The planet would be in a perpetual state of flux, its crust rising and falling by hundreds of meters in a cycle that would be dictated by its orbit. This is not a slow process. It would be a constant, violent, and devastating dance. The mountains, once symbols of permanence and stability, would be ripped apart and folded into new, impossible shapes. The continents, once the foundation of all life, would be in a state of constant, frenzied motion, a deadly ballet of colliding landmasses. This constant kneading would generate an incredible amount of internal friction, and heat. The Earth's core, already a molten sea, would become a churning violent inferno. This would lead to a catastrophic increase in volcanic activity. On our old Earth, a volcanic eruption is a rare and terrifying event. In our new reality, the entire surface of the planet would be a continuous volcanic eruption. There would be no dormant volcanoes, no quiet geological periods. The surface would be a sea of molten lava, a landscape of perpetual fire and destruction. The very ground would be alive, a living, breathing testament to the immense power of the star above. A lesser-known scientific fact is that this type of gravitational kneading, known as tidal heating, is responsible for some of the most bizarre and beautiful phenomena in our solar system. Jupiter's moon Io, for example, is the most volcanically active body in our solar system. It's not because of its own internal heat, but because the immense gravitational pull of Jupiter and the other Galilean moons constantly stretches and squeezes it, generating enough friction to keep its interior a molten sea of fire. Our Earth in Scuti's embrace would be a new kind of Io, a planet-sized volcanic inferno, a silent scream of cosmic violence. The earthquakes would not be a series of discrete events, but a continuous planet-wide seismic storm. The ground would never be still. There would be no safe place, no stable ground. The very concept of up and down would be a matter of constant re-evaluation as the planet's surface rose and fell under the immense tidal forces. This is a place where the laws of geology as we know them would be completely rewritten. The planet is not a passive object. It is a dynamic living entity being tortured and remade by the force of its star. This raises a fascinating and unsettling question. In this new reality, would the planet's core still function as a dynamo, generating a magnetic field? The churning of the molten core is what creates our magnetosphere, but would the violent, chaotic kneading of the tidal forces disrupt this process? The very mechanism that once protected us could be rendered useless by the same force that is tearing the planet apart. It's a beautiful and tragic paradox, a reminder that the forces that create can also destroy, and that the balance between order and chaos is a fragile and fleeting thing. The weight of the colossal star would not just affect the planet's geology, it would affect its very shape. The planet would be elongated, a cosmic teardrop being pulled towards Scuti. This change in shape would also affect the planet's rotation, slowing it down as it struggled against the immense gravitational tug. The days would become longer, the nights longer still, until eventually the planet might become tidally locked, a state of perpetual agonizing stasis. The weight of Scuti is a powerful and destructive force, a new reality that would reshape our world from its core to its crust. The gentle hum of our old planet's processes has been replaced by the roar of volcanic fire and the grinding of tectonic plates. The stability we once took for granted is a distant memory replaced by a beautiful, terrifying, and constant dance of destruction. Our journey is not just a story of a planet's end. It is a story of a planet's transformation, a final violent act in the long and beautiful symphony of the cosmos. The planet has become a forge of fire and chaos, its body reshaped by the immense gravitational forces. But as we witness the final fiery dance of our world, a deeper, more poignant question emerges: what of life? On our old Earth, life is a testament to the planet's resilience and adaptability. From the deepest ocean trenches to the highest mountain peaks, life finds a way. But in this new reality, where the very conditions for life have been erased, what would be the fate of the last living things? This section is a quiet elegy, a farewell to the complex, beautiful, and utterly fragile tapestry of life as it confronts its final fading song. The immediate destruction of the surface, the vaporization of the oceans, and the stripping of the atmosphere means that all life as we know it, from the grand forests to the teeming oceans, would be extinguished almost instantly. But let's pause for a moment and consider the most resilient of creatures, the extremophiles. These are not the animals and plants we are familiar with. These are the bacteria and archaea that thrive in conditions we would consider lethal. They live in the boiling hot vents at the bottom of the ocean, in the freezing cold of Antarctica, and in the toxic, acidic environments of volcanic springs. They are life's last, most stubborn survivors. In our old reality, these extremophils were a beautiful paradox, a quiet reminder that life is more resilient than we often imagine. But in the embrace of Scuti, even they would be pushed to their limits. The oceans their home would boil away. The thermal vents, their source of energy, would be destroyed as the planet's internal chaos became too great. But perhaps, just perhaps, for a fleeting moment, a few of these creatures might cling to existence. They might retreat into the deepest, most insulated parts of the planet's crust, clinging to the last remnants of liquid water, a final, desperate gasp of life. This raises an interesting biological question, a thought experiment known as the panspermia theory. This is the idea that life might not have originated on Earth, but was brought here by a meteor or comet from another planet. Now, in our new reality, as the stellar wind from Scuti strips away our planet's very surface, could a microscopic piece of Earth, a tiny extremophile-carrying rock, be blasted into space? It's a beautiful, desperate thought, a small silent act of defiance, a final fading hope that a piece of Earth's life might escape its fiery fate and begin a new journey through the cosmos. It's a testament to life's intrinsic desire to continue to spread, to find a way no matter how impossible the odds. A lesser-known scientific fact is that some organisms, like tardigrades or water bears, can survive in the vacuum of space, enduring incredible amounts of radiation, extreme temperatures, and a complete lack of water. These are the creatures that might, in some miraculous scenario, survive the initial cataclysm. But their survival would be fleeting. They would be exposed to the unrelenting radiation from Scuti, a torrent of high-energy particles that would tear apart their DNA and destroy their cellular structure. Their final act would not be a new beginning, but a slow, silent, and inevitable end. The passing of life is a profound and sad moment in our story. It's a moment that forces us to confront our own mortality, our own fragility in the face of the cosmos. Our planet, once a vibrant living entity, is now a silent, fiery orb. The beautiful, complex symphony of life has been replaced by the roar of a star. The millions of species, the intricate ecosystems, the slow, beautiful process of evolution, all of it is gone. It's a reminder that life, for all its beauty and resilience, is just a fleeting moment in the vast, almost eternal story of the universe. This brings us to a deep philosophical question. What is the purpose of life if it is so easily extinguished? Is the purpose of life simply to exist, to sing its song for a brief moment before fading into silence? Or is there a deeper meaning, a cosmic purpose to our brief, beautiful existence? The answer perhaps is not a grand universal truth, but a personal one. The purpose of life is the living itself, the brief, beautiful flicker of consciousness that allows us to ask these very questions. Our journey into the heart of Scuti is not just a story of a planet's end. It's a story that forces us to appreciate the miracle of our own existence, the incredible unlikelihood of it all. The final song of life is not a roar of defiance. It is a quiet, gentle fade into silence. It is a slow, elegant disappearance, a return to the cosmic dust from which we came. The matter that made up our bodies, our thoughts, our dreams, will not be destroyed. It will be remade, scattered, and eventually one day become a part of something new. Our story is not an ending. It is a transformation, a quiet, beautiful farewell to the intricate dance of life on a small blue marble, and a gentle welcome to the vast, almost eternal story of the cosmos. We've followed Earth on its final fiery journey, a story of transformation and loss. But now let's pivot our gaze from our small personal tragedy to the grand cosmic stage itself. Our star, Scuti, is not just a destroyer. It is a monument to a particular phase of stellar life, a cosmic echo of a past that stretches back billions of years. To understand our new home, we must first understand its history, a history written in the language of fire and light. This section is a meditation on the life cycle of hypergiants, a quiet exploration of a story that is both ancient and eternally relevant. UI. Scuti began its life not as a red hypergiant, but as a hot, luminous blue supergiant. These are stars born from the most massive clouds of gas and dust giants of the cosmos, burning with a ferocious intensity. They are the rock stars of the universe, living fast and dying young. The core of such a star is a furious engine, fusing hydrogen into helium, then helium into carbon, and so on, creating a cascade of heavier and heavier elements. This process, a cosmic alchemy, is what creates the very building blocks of our universe. The oxygen. We breathe the carbon in our bodies and the iron in our blood. The life of a blue supergiant is a frantic race against time. Their immense mass creates enormous gravitational pressure, forcing the core to burn its fuel at an incredible rate. They live for only a few million years, a fleeting moment in the cosmic timeline, before their cores run out of fuel. This is a crucial scientific concept. The more massive a star, the shorter its life. It's a beautiful, tragic paradox. The stars that shine the brightest and burn the hottest are also the most ephemeral. Our sun will live for 10 billion years, a long and stable life. UI Scuti and stars like it live for a fraction of that time, a glorious short-lived blaze. As the star's core begins to run out of fuel, the balance between the outward pressure of the fusion and the inward pull of gravity is disrupted. The star begins to expand its outer layers, swelling dramatically. The star cools, and its color shifts from a brilliant blue to a deep turbulent red. It becomes a red hypergiant, a colossal, unstable, and magnificent entity. This is the stage of its life we are witnessing, the final glorious act before its inevitable demise. A lesser-known fact about these stars is that they are surrounded by shells of gas and dust remnants of their earlier, more violent stages. These shells, known as nebulae, are a silent testament to the star's turbulent past. They are the cosmic equivalent of tree rings, a record of the star's history, a memory etched in gas and light. We are now in a new planetary neighborhood, a place filled with these cosmic ghosts, a silent and beautiful reminder of the star's journey. This brings us to a profound philosophical question. Is the universe in a state of eternal repetition? Are these stars and the planets that orbit them simply part of a cosmic cycle of birth, death, and rebirth? The matter that made up UI Scuti will one day be scattered across the cosmos in a spectacular supernova explosion, and that matter will in time become the raw material for a new generation of stars and planets. We are a part of that cycle, our very bodies, a collection of atoms forged in the heart of a star that died billions of years ago. Our journey into the heart of UI Scuti is not just a story of a planet's end. It is a meditation on this eternal cyclical nature of the cosmos. The history of UI Scuti is a powerful metaphor for the transient nature of all things. Like the star, we are all born, we live, and we eventually die. Our lives, for all their complexity and beauty, are just a fleeting moment in the grand cosmic timeline. But even in our transience, we are a part of something larger, a vast and beautiful cycle of existence. Our atoms will not be destroyed. They will be scattered, remade, and will eventually become a part of something new. This is the deeper, quieter layer of our story. Beyond the fire and the fury, beyond the impossible scale, lies a quiet, almost melancholic truth. We live in a universe where everything from the smallest atom to the largest star is a part of an eternal, beautiful dance. Our journey into the heart of UI Scuti is an invitation to see this dance, to appreciate its beauty, and to find a strange comfort in the knowledge that even in our end, we are a part of a much larger, more magnificent beginning. The journey through UI Scuti's gravity well has shown us the end of our world, but let's now expand our view beyond this one star and this one planetary system. Our new home is a cosmic graveyard, a place where the remnants of a star's past are scattered throughout its immense gravitational influence. But this isn't a unique phenomenon. The universe is filled with such places, silent monuments, to the death of stars and the beautiful haunting legacies they leave behind. This section is a quiet reflection on the universe's many forgotten worlds and the philosophical weight of cosmic cycles. Scuti, as a red hypergiant, is shedding its outer layers in a constant stream of gas and dust. This creates a vast, diffuse nebula, a glowing shroud of its own making. This nebula, filled with the atoms and molecules that once made up the star's outer atmosphere, is a testament to its long turbulent life. But imagine for a moment that we could somehow see through this brilliant haze. What would we find? We would find the remnants of other stars and other planets, cosmic ghosts from a forgotten past. A lesser-known scientific fact is that our galaxy, the Milky Way, is littered with the corpses of dead stars. These are not just supernovas, but the silent, cold remnants of stars that have lived their lives and faded away. There are white dwarfs, the dense, tiny cores of stars like our Sun. There are neutron stars, the collapsed cores of massive stars spinning with an incredible speed. And there are black holes, the ultimate cosmic vacuum cleaners, born from the collapse of the most massive stars. These are the celestial tombstones of the universe, and their presence tells us a story of a long and beautiful history. This raises a fascinating and unsettling question. What happens to the planets that once orbited these dead stars? Do they simply cease to exist? Or do they become forgotten worlds, silent monuments to a long-gone era? It's a beautiful, melancholic thought. Imagine a planet once teeming with life, now orbiting a cold, dark white dwarf. Its oceans would be frozen solid, its atmosphere a thin, icy crust. It would be a world of perpetual twilight, a ghost planet orbiting a ghost star. These are the forgotten worlds of our galaxy, and their story is a silent echo of our own. The concept of stellar graveyards is a powerful metaphor for our own lives. We build our lives. We create memories. We leave behind a legacy. But in the grand scheme of things, our lives and the lives of our planets are just a fleeting moment. The universe will continue its dance long after we are gone. Our memories will fade, our legacies will be forgotten, and our planet will become a silent, forgotten world, orbiting a new, different kind of star. This brings us to a deep philosophical mystery. What is the purpose of existence if it all eventually fades into nothingness? Is the purpose of a star to simply burn to shine brightly for a brief moment before fading into a silent corpse? Or is there a deeper meaning, a cosmic purpose to its fiery, beautiful life? The answer perhaps is not to be found in the end, but in the journey. The purpose of a star is the burning, the shining, the creation of new elements. The purpose of a planet is the orbiting, the life, the consciousness. The purpose of existence is the experience itself, the beautiful, tragic, and fleeting moment of being. The silent dance of cosmic dust, the ghosts of a star's past, the chaos of a new planetary neighborhood, all of it is a reminder of the beautiful cyclical nature of the universe. Nothing is ever truly destroyed. It is simply transformed. The matter that made up our oceans, our mountains, and our very bodies will not simply cease to exist. It will be scattered, reforged, and eventually one day become a part of something new. Our story, in its final fiery act, is not an ending. It is a new beginning, a tiny contribution to the grand ongoing symphony of the cosmos. We've contemplated the silent graveyards of the cosmos, but let's now return to the heart of our story, to the colossal presence of Scuti. We have described its immense mass and its destructive power, but let's delve deeper into the fundamental physics that governs this new reality. The core concept we must now confront is the beautiful mind-bending reality of general relativity, and how the fabric of space-time itself is not a flat, unchanging stage, but a dynamic, flexible entity that is warped and bent by the presence of a colossal star. Albert Einstein's theory of general relativity revolutionized our understanding of gravity. He proposed that gravity isn't a force that pulls objects together, but a result of mass and energy warping the fabric of space-time. The more massive an object, the greater the warp. Imagine space-time as a huge, flat rubber sheet. If you place a bowling ball in the middle, it creates a dip. If you then roll a marble nearby, it will follow the curve of that dip, appearing to be pulled towards the bowling ball. The bowling ball is Scuti, and the marble is our Earth. The dip it creates in the fabric of space-time is not a gentle curve. It's a deep, profound well, a chasm that affects everything within its reach. This warping of space-time would have a tangible effect on our planet. We've already discussed how time would be dilated with clocks on our planet ticking slower. Relative to those far away, this is a direct consequence of space-time being stretched and bent by Scuti's immense gravity. The closer you are to the star, the more pronounced the effect. Our planet in its close orbit is at the very edge of this immense well, and the flow of time on its surface would be a slow and deliberate crawl from the perspective of an outside observer. A lesser-known scientific fact is that this warping of space-time also affects the path of light. On our Earth, light travels in a straight line, but in the gravitational well of Scuti, the light would follow the curve of space-time bending around the star. This phenomenon, known as gravitational lensing, is a powerful tool for astronomers, allowing them to see distant galaxies that would otherwise be obscured. But for us on our new planet, it would mean that the sky would be a place of optical illusions. We might see the light from a distant star being bent and stretched around Scuti, creating a distorted multiple image of the same object. The very light from Scuti itself would be bent and twisted, creating a fiery psychedelic spectacle. This raises a fascinating and unsettling question in this warped reality. Can we even trust our own perception? Our eyes and our brains are built to interpret a world where space-time is relatively flat, but in a place where it is profoundly bent, our senses would be overwhelmed by the bizarre and beautiful distortions. The lines we think of as straight would be curved, the images we see would be warped, and the very concept of a fixed point in space would become a fluid, flexible idea. Our reality would be a strange, beautiful, and terrifying new place. The immensity of Scuti's mass also raises a philosophical paradox. We can measure its mass, we can understand the physics that governs it, but can we truly comprehend it? Our minds are built to understand the world on a human scale. We understand the weight of a stone, the height of a mountain. But the mass of a hypergiant, a star that is hundreds of times more massive than our sun, is a concept that our brains can only grasp in an abstract, mathematical sense. It's a number of fact, but not a lived reality. This is the paradox of infinite scale, the idea that our human comprehension is limited by the very scale of our existence. And so we've gone from the fiery surface to the very fabric of space-time itself. Our planet, now a silent, fiery orb, is not just being destroyed. It is a participant in a grand cosmic experiment. It is a tiny marble following the curve of a colossal bowling ball. Its every moment, its every particle a testament to the beautiful mind-bending reality of general relativity. Our journey is not just a story of a planet's end. It is a story that forces us to let go of our assumptions, to embrace the impossible, and to find a strange, melancholic beauty in the cosmic unknown. We have delved into the profound physics of a hypergiant, exploring how it warps space-time and redefines our understanding of reality. But as we stand at the edge of this gravitational well, another deeper question arises, one that moves from the realm of science into the realm of philosophy. What does it mean for our comprehension, for our very consciousness, to grapple with a star so large that it challenges the limits of human thought? This section is a quiet rumination on the paradox of infinite scale, a beautiful and humbling acknowledgement that there are some things in the universe that we can measure but may never truly comprehend. Our brains are a remarkable piece of biological machinery, but they are a product of our environment. They evolved to navigate a world of finite, tangible things, the size of a rock, the height of a tree, the distance to the next hill. Our language, our metaphors, our entire cognitive framework is built on this human-scale reality. We can talk about a star being billions of kilometers in diameter, but the words themselves are just placeholders for a concept our minds struggle to visualize. The number, while mathematically precise, becomes a kind of mystical incantation, a sound that signifies something vast and incomprehensible. This is the heart of the paradox. We have the tools to measure the universe, but not the capacity to fully experience its scale. We can calculate the mass of Scuti, a number so large it requires scientific notation. We can use complex equations to describe how it bends spacetime, but to truly feel the weight of that mass, to truly experience the warping of time and space, is beyond our grasp. Our consciousness, for all its beauty and complexity, is a small, fragile thing, a single flickering candle in the immense dark expanse of the cosmos. A lesser-known scientific fact is that even the most powerful computers in the world, while they can model the physics of Scuti, cannot create a true felt reality of its scale. They can show us a graphic representation, a simulation of a fiery orb, but it is just that, a representation. The reality of it, the sheer overwhelming presence of a star that could swallow our entire solar system, remains a concept locked behind the cold, hard logic of mathematics. The true nature of Scuti exists in a place that is beyond our screens, beyond our words, and perhaps beyond our minds. This raises a profound philosophical question. What is the true nature of knowledge? Is knowledge simply the collection of facts and figures, the ability to measure and predict? Or is it something deeper, a sense of lived, felt reality? We know about Scuti. We can calculate its properties, but do we truly know it? The answer, perhaps, is no. Our knowledge is limited by the very scale of our existence. We are a part of the universe, but we are also separate from it. Tiny observers looking out at a grand, beautiful, and utterly alien world. The paradox of infinite scale is not a failure of science. It is a beautiful and humbling testament to its power. Science allows us to peer into the abyss of the unknown and to glimpse a world that defies our intuition. It gives us a language to talk about the impossible. But it also forces us to confront our own limitations, to acknowledge that for all our brilliance, we are still a small and fragile part of a much larger, more mysterious whole. And so, as we conclude this part of our journey, let's sit with this thought. Our planet, now a silent, fiery orb, is not just being destroyed. It is being remade by a force that is beyond our comprehension. Its fiery end is a part of a larger cosmic story, a story that is so vast, so beautiful, and so terrifying that we can only ever hope to glimpse a small fleeting part of it. The gentle hum of our old world is now a silent roar, a reminder that we are but small, curious travelers in a universe of infinite scale. We have explored the physics and philosophy of our new reality, but now it is time to face the inevitable conclusion of our story. Our journey has not been one of survival, but of transformation. The planet, once a vibrant home, is now a silent, fiery orb, a testament to the immense power of its new star. This section is a quiet, poetic reflection on Earth's final moments, a gentle return to nothingness, as it begins its long, slow fade into the heart of Scuti. The death of a planet is not a violent, instantaneous event, but a slow, majestic, and elegant disintegration. We are no longer speaking of volcanic eruptions and tidal forces. We are speaking of the final decisive act. The stellar wind, the immense gravity, the friction of the star's tenuous outer atmosphere. All of these forces, once a torrent of destruction, now act as a slow and constant pull. Our planet's orbit, already in a death spiral, is now a graceful inward dance. It is not a plunge. It is a slow, methodical descent into the heart of the star. Imagine for a moment the planet's surface. What was once a sea of molten lava is now being stretched and torn apart. The tidal forces, once a constant kneading, are now a relentless tearing. The planet's molten crust, already a thin and fragile shell, is now being ripped open, revealing the fiery core beneath. The planet is not just melting. It is being unmade, its very structure being pulled apart by the immense gravitational force. It is a beautiful, terrifying spectacle, a silent scream of cosmic violence. A lesser-known scientific fact is that as a star nears the end of its life, its outer layers are not a uniform dense gas. They are a diffuse, tenuous plasma, a ghostly halo of ionized matter. Our planet in its final orbit would be flying through this ghostly atmosphere, the friction creating a brilliant, fiery display. The planet would glow not from its own internal heat, but from the immense friction of its slow descent. It would be a final, beautiful light show, a last glorious gasp before its inevitable end. This raises a profound philosophical question. What does it mean to disintegrate? Does our planet simply cease to exist? Or does it become something else? The matter that made up our mountains, our oceans, and our very bodies will not be destroyed. It will be remade, scattered, and become a part of Scuti. Our planet will not be an ending. It will be a new beginning, a tiny, almost unnoticeable addition to the immense fiery body of the star. It's a humbling thought, a quiet reminder that even in our end, we are a part of a larger, more magnificent whole. The final moments would be a silent, graceful return to the cosmos. The planet would not hit the star with a bang, but would be slowly, elegantly absorbed. The immense gravity would pull it apart, atom by atom, molecule by molecule. The planet's fiery core would merge with the star's core, its silicate crust with the star's outer layers. It would be a final quiet act of cosmic communion, a return to the fire and light from which all things came. And so we have come to the end of our journey. The planet, a beautiful, fragile home, has made its final, beautiful descent. The gentle hum of our world has been replaced by the silent roar of a star, and the life we once knew has been replaced by a new, fiery reality. This is not a story of an ending. It is a story of a transformation, a quiet, beautiful farewell to one chapter of our existence, and a gentle welcome to the next. We have witnessed the graceful and tragic end of our world, a quiet return to the heart of its new star. But in the final act of our story, a new question emerges, a question of legacy. A life, whether it is a human life or a planetary life, leaves behind a memory, a story, a mark on the world. But what is the legacy of a tiny planet swallowed by a cosmic king? This section is a meditation on the beautiful and humbling truth of our cosmic insignificance, a reflection on how our planet's end would affect Scuti and what that tells us about our place in the universe. The death of our planet would be a momentous, catastrophic event for us, a final, beautiful goodbye to everything we have ever known. But for Scuti, it would be nothing. It would be a drop of water in an ocean, a single grain of sand on a vast beach. The mass of our planet is a staggering. An immense number beyond a weight we can barely comprehend. But Scuti's mass is estimated to be around 10 to 30 times that of our Sun. Let's take the lower end of that estimate, 10 solar masses, which is roughly. The difference in scale is so vast that our planet's mass would be completely insignificant. A lesser-known scientific fact is that stars like Scuti are constantly shedding mass at a phenomenal rate. They are losing the equivalent of our Sun's mass every few thousand years. So in the grand scheme of the star's life, the addition of our planet's mass would be less than a single moment of its natural decay. The star would not even notice our planet's arrival. The atoms and molecules of our world, the iron from our core, the silicates from our crust, The carbon from our bodies would be absorbed into the star. Their existence as a planet erased their memory. A silent whisper in the colossal roar of the star. This raises a beautiful and humbling philosophical question. Does a story have to have a grand universal impact to have meaning? Our planet's story is one of life, love, and consciousness. It is a story of beautiful sunsets, of deep oceans, and of the quiet, hopeful hum of existence. And yet this beautiful, complex story would end in a way that is utterly insignificant to the universe around it. The end of our world would not cause a ripple in the fabric of space-time. It would not change the course of Scuti's life, and it would not be a story told in the far reaches of the cosmos. Our story, in its final fiery act, is a personal one. The humility we find in this insignificance is not a cause for despair. It is a cause for celebration. Our story is not defined by its ending, but by its existence. The fact that we are here, that we have had this moment to live, to love, to be, is a miracle in itself. Our journey into the heart of Scuti has shown us the immense, beautiful, and terrifying scale of the universe. It has forced us to confront our own fragility, our own transience. But in that confrontation, we find a new kind of strength. We find a new kind of meaning. We find a new kind of beauty. Our planet's legacy is not a mark on the star, but a memory in our minds. It is a story we have told, a journey we have shared, a beautiful and poignant meditation on the nature of life, death, and the cosmos. The atoms that made up our world will not be destroyed. They will become a part of something new. They will be scattered, reforged, and eventually one day become a part of a new star, a new planet, a new life. Our story is not an ending. It is a transformation, a quiet, beautiful farewell to one chapter of our existence and a gentle welcome to the next. We have traveled through fire and time, through the beautiful chaos of a new reality and the quiet humility of our own insignificance. We have seen a planet unmade and a star in its final glorious act, but the story does not end with the death of a planet or the absorption of its matter. It ends with the star itself, a majestic, beautiful being that, like everything else in the universe, is not eternal. This final section is a quiet farewell, a meditation on the long, slow fade of Scuti and the cyclical nature of life, death, and the cosmos. Scuti is a hypergiant, and its life is a frantic, beautiful race against time. It has burned its fuel at an incredible rate, and its demise is not a matter of if, but of when. The star's core, which has been fusing heavier and heavier elements, is reaching its limit. It has likely already fused carbon, oxygen, and neon. But eventually, it will reach a point where it can no longer fuse elements, and the delicate balance between the outward pressure of the fusion and the inward pull of gravity will be broken for good. The star, unable to support its own immense weight, will collapse in on itself. This collapse would not be a quiet event. It would be a catastrophic, planet-shattering, universe-shaking event, known as a supernova. In a matter of seconds, the star's core would collapse, and the outer layers would rebound in a violent, unimaginably bright explosion. The supernova would be so luminous that it would outshine an entire galaxy for a brief period. The light from this explosion would travel across the cosmos, a final brilliant testament to a life lived in a glorious blaze. A lesser-known scientific fact is that this supernova explosion is a creative, not just a destructive force. It is in this final violent act that the heaviest elements in the universe are forged. The gold in your rings, the platinum in your jewelry, and the uranium that powers our nuclear reactors, all of it was created in the heart of a supernova explosion. The death of a star is not an ending. It is a new beginning, a final beautiful act of cosmic alchemy. The remnants of Scuti would not be a star but something else entirely. The core, having collapsed, would either become a neutron star, a tiny, incredibly dense ball of matter that spins at an incredible speed, or a black hole, a point in space-time with a gravitational pull. so strong that not even light can escape. The outer layers of the star, the atoms and molecules that once made up its beautiful fiery body, would be scattered across the cosmos, a vast, beautiful nebula of gas and dust. This is the ultimate end of our journey, the final destination of our story. This brings us to a profound philosophical question. Is there a grand design to this cycle of birth, death, and rebirth? Are we and our universe a part of a larger, more beautiful story? The answer perhaps is not to be found in a book or a scientific paper, but in the quiet, gentle hum of our own existence. We are here, we are alive. We are a part of this beautiful, terrifying, and magnificent cosmos. Our journey into the heart of Scuti was not a journey of a planet's end, but a journey of our own awakening. A quiet, beautiful reminder that we are all made of stardust, and to stardust we will all eventually return. Our journey now comes to a close. We have traveled far and fast, from a familiar blue sky to a searing crimson inferno, from the gentle rhythm of time to its beautiful, mind-bending warp. We have seen a world unmade a star in its final glorious act and the quiet, humbling beauty of our own insignificance. It's time now to gently bring your awareness back to the room you are in. Feel the soft brush of the air on your skin, the quiet, steady rhythm of your own breath. The cosmic roar has faded and the gentle hum of your own world has returned. I'd like to gently ask one last time, where is the place you're staying now? The time in that place at this very moment. How is it flowing in this quiet moment, in this peaceful space? Remember that the atoms that make up your body were forged in the heart of a star, and the stories in your mind are as vast and beautiful as the cosmos itself. So before you drift off, take a moment to be grateful for this beautiful, fleeting gift of existence. Sleep well, my companion, wherever and whenever you are. Sweet dreams.